Okay, some series to integral calculus. We proceed in. Some series to integral calculus. This is what we are proceeding in. Okay, I'm completely drenched. It is raining heavily outside. Okay, so we will change it. Okay, better. Okay, it is raining badly outside. Okay, for past 3 days, I believe it is raining continuously. Okay, so some series to integral calculus. This is what the discussion we are making. Some series to integral calculus. Can we achieve? Can we achieve? Can we achieve summation of a series through integral calculus? This is a war that we have waged. Is it really possible to calculate some series through integral calculus? And the difficult one, what we have taken as an example, the difficult one, whatever we have taken as an example is 1 minus 2. Okay, what is your sum and series? We have discussed in the past session. What is your sum and series? The sum series is 1 summation of a series, summation of a series of a number, summation of a series of a number. Okay, what is the series? Series is 1 comma, or the first number in the series is 1, and next number in the series is minus 2, then 3, then minus 4, then 5, then minus 6. Okay, okay. So what is the sum series that we are taking? The sum series we have taken as an example is 1 minus 2, 1 minus 2, and then 3 minus 4, 5 minus 6, 7 minus 8. This is a series that we have taken example into. If I divide into n different parts, if I divide into n different parts, then first one is 1, second is minus 2, third one is 3, fourth one is minus 4, and fifth one is 5, sixth one is minus 6. Can I represent it through algebraic equation? We can represent it through algebraic equation. The any xth term, first term is 1, second term is minus 2, third term is 3, fourth term is minus 4, fifth term is 5th. Then if I want to represent it through algebraic equation, then it will be x at x position. It will be x into minus 1 to the power x plus 1. X into in bracket minus 1 to the power x plus 1. Okay, if x is 1, then 1 into minus 1 to the power 2, that is 1. When x is 2, the second position, then it is 2 into minus 1 to the power 3, that is minus 2. If it is x equal to 3, then 3 into minus 1 to the power 3 plus 1, that is 1. Means it will become 1 minus 2, 3 minus 4, 5 minus 6, 7 and so on. Okay, this is what is the, now what you need. Someone would ask, okay, thank you very much. What you need? We want summation of this 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7, something like that. Can someone calculate summation of it? Oh, it's very simple. They are neutralizing each other. 1 minus 2, it's not that easy. It's not that easy. Okay. Consider in examination it is written like this. Can you compute 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8 plus 33? Can you compute? Plus 33. This is what is mentioned in the examination. There can be many ways to solve it. That the most traditional way to solve it is successive approximation. This is what we have talked. In successive approximation, what we do, so we will demonstrate again. I believe tens of times we have demonstrated it, successive approximation. So we will do it again. Okay, this is my x-axis. Okay, this is x-axis. Consider this is x-axis. Then this is x equal to 0, 1, 2, 3, 4, 5, 6, and so. I have function over x, and that is x into minus 1 to the power x plus 1. When x is 1, then consider this is y-axis. This is y-axis. This is y-axis and this is x-axis. In that manner, if I talk about function over x at x equal to 1, then it is x into minus 1 to the power x plus 1. So at x equal to 1, function over x is 1. At x equal to 2, function over x is minus 2. At x equal to 3, function over x is 3. 3. At x equal to 4, function over x is minus 4, like so. Okay, what you want? I want to add all the verticals that are emanating at any x equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Okay, is it easy or difficult? I don't know. It is easy or difficult? I don't know. But this is how it is. So x equal to 1, fx is 1. At x equal to 2, fx is minus 2. At x equal to 3, fx is 3. I have to add, you mean sigma x equal to 1 to n function over x, means function over x at x equal to 1 plus function over x at x equal to 2 plus function over x at x equal to 3 plus function over x at x equal to 4 plus function over x at x equal to n. Yeah, absolutely. This is what we want. Successive approximation says consider there is a consider this is fx, function over x equal to x into in bracket minus 1 to the power x plus 1. Consider there is a function called gx. Consider there is a function called gx. Consider there is a function called gx. Fx is a discrete function. What we talked right now, fx equal to x into in bracket minus 1 to the power x plus 1 is a discrete function. It is not a continuous function. What I mean is, if this is x-axis, if I take x equal to 1, then fx is 1. If I take x equal to 2, then fx is minus 2. If I connect all these points, x equal to 1, this point, then this point, if I connect by a line, This is fx, and it is not a continuous function. This function is sampled. This function is, it has value only at x equal to 1, 2, 3, 4, not in between. So this is typically called point mass function, PMF, point mass function. Okay, we want density function. Density function means continuous function. Okay, why you want continuous function? We need continuous function because we are doing calculus. For calculus, we need continuous function. Differentiation works on continuous function. Integration works on continuous function. Integration calculates area of a curve. Consider this is gx. Consider this is gx. If this is gx, this is a continuous function. If I say gx dx from x equal to 1 to x equal to n, it calculates area under gx from x equal to n to x equal to 1. Limit x equal to 1 to n. Limit x equal to 1 to n. Gx dx will calculate area under gx from x equal to 1 to n. I believe it is absolutely all right. This is what the integration is. What you want. I want sigma x equal to 1 to n fx, where fx is x into in bracket minus 1 to the power x plus 1. This is fx. I want this summation. I want summation of all the vertical. At x equal to 1, vertical is 1. At x equal to 2, vertical is minus 2. At x equal to 3, vertical is 3. At x equal to 4, it is minus 4, like so. I want addition of all the vertical. Okay, that addition is possible through integration only when there is a continuous function. Yeah, there is a continuous function called gx. Gx dx will give area from lower limit to higher limit. How to calculate gx? That is an art. Means what is the representation of a discrete function into continuous function? That is a question mark here. To solve this question mark, what is representation of a discrete function to continuous function? We will do lot of drama here. Anyway, now I have at x equal to 1, I have a vertical. At x equal to 2, I have a vertical. Can I think about a area strip between x equal to 1 and x equal to 2? This area strip would go like this and it will hit gx. This is gx. I mean limit x equal to 1 to 2 gx dx. Limit x equal to 1 to 2 gx dx should be exactly same as fx. The fx what we talked now, that is x into minus 1 to the power x plus 1. This fx at, this is x equal to 1. This is x equal to 2. If I say fx at x equal to 1, then I have fx. If I say between x equal to 1 and x equal to 2, I have an area strip that is hitting gx. What I am trying to say, area strip with gx should be exactly same as fx on left hand side of this area strip. Means fx equal to fx at x equal to 1 equal to limit x equal to 1 to 2 gx dx. I mean, if I take it in a generic manner, then fx at x equal to limit x equal to x plus 1 gx dx. Dx integration x equal to x plus 1, that should be same as fx at x equal to x. If this is x equal to x, then what is fx? I don't know what is. Consider this is fx. This fx should be exactly same as x to x plus 1 integration of gx. What are you trying to say? I am trying to say, if I have fx at different x, if I have fx at difference x, each vertical should be same as exactly as area on right hand side that will go and hit gx. Means fx at x equal to 1 plus fx at x equal to 2 plus fx at x equal to 3 plus fx at x equal to n should be equal to limit x equal to 1 to 2 gx dx plus x equal to 2 to 3 dx plus x equal to n plus 1, because right hand side area end will be n to n plus 1 dx means total sigma x equal to 1 to n fx will be equal to limit 1 to n plus 1 dx. These are the fundamental that we are proposing, and if someone solve it, then he has to find gx, and then at the end he has to calculate it anyway. Now we'll come to our main business. Main business is we want to add a summation series where at x equal to 1 height is 1, x equal to 2 height is minus 2, at x equal to 3 height is 3. Now question is arising, this x is important or height is important? Anyone would reply height is important. We want addition of height where height is 1 minus 2 3 minus 4 5 minus 6 7. Does not matter one height belongs to x equal to 1 or x equal to 5. No one. In examination it is purely written 1 plus minus 2 plus 3 plus minus 4 plus 5 plus minus 6 up to 33 can you calculate. Now you do whatever you want to do. Apply whatever formula you want to apply. We want answer. Okay. Now let's consider that at x equal to 1, I have x equal to 1, I have a vertical called 1. At x equal to 2, I have a vertical called 3. Hop, 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 hop. At x equal to 3, I have a vertical of 5. At x equal to 4, I have a vertical of 7. At x equal to 5, I have a vertical of 9. Okay, where minus will go. At x equal to 1 and a half, I have a vertical of minus 2. At x equal to 2 and a half, I have a vertical of minus 4. At x equal to 3 and a half, I have a vertical of minus 6. In that manner, means I am cutting x-axis at half distance. At half distance. I believe it is understandable. If that is the case, then x equal to 1, 2, 3, 4, 5, 6, 7, 8, n will be occupied by fx equal to 1, 3, 5, 7, like that. Then what is the equation? Then equation is 2x minus 1. 2x minus 1, if x is 3, then height is 5. When x is 7, then height is 13. When x is 5, then height is 9, like so. What about minus 1? That is again 2x minus 1. Same, all are 2x minus 1. Consider x equal to 1 and a half. That is 3 by 2. 2 into 3 by 2 minus 1. That will come as 2. 2. Okay, I can say it is minus and in bracket 2x minus 1. Means everything is 2x minus 1. 2x, if I take 5 by 2, that is 2 and a half. 5 by 2 into 2, 5 minus 1, 4. Minus outside weighting, minus in bracket 2x minus 1. Then it is minus 4. All are following equation 2x minus 4. 2x minus 4. Okay, understandable, right? Consider I say, instead of I say minus 2, minus 4, minus 6, I say 2, 4, 6. Then it is exactly same 2x minus 1. Okay, now let's consider what I am trying to do. I am trying to first compute the addition of x equal to 1, 2, 3, 4, 5. X equal to 1, 2, 3, 4, 5 up to n. This n is different than what n at the beginning we are thinking. Okay, then I'm trying to add all the vertical at x equal to 1 and a half, 2 and a half, 3 and a half, 4 and a half, like so, and that is 2, 4, 6, 8. I'm sorry, 2, 4, 6, 8. If I add both, then I'll subtract first and second. Makes sense? First is 1 plus 3 plus 5 plus 7 plus 9. Whatever I get minus what I get with 2 plus 4 plus 6 plus 8. Then I get same thing, 1 minus 2 plus 3 minus 4, like so. But both of them, they follow same formula, 2x minus 1. Okay, let's start with the odd one. Odd one is 1, 3, 5, 7 and so on. Okay, fx equal to x plus 1. Because if I say x equal to 1, 2, 3, 4, 5, 6, then at x equal to any x, I have fx, that is 2x minus 1. And that is x to x plus 1, it will be area strip that will go and hit gx continuous function. Both should be exactly same. Fx equal to limit x to x plus 1 gx dx. Okay, let's try what is fx. Fx is 2x minus 1. Let's try gx with 2x. With our past experience, we'll try with the 2x. Let gx is 2x, then it is 2x square by 2, x square. X square limit x to x plus 1. That will come as x square plus 2x plus 1 minus x square, 2x plus 1, whereas we want 2x minus 1. Then in that manner, it would become, we'll try again, we started with 2x, gx equal to 2x. Now gx, we will try 2x minus 2, because I have to get 2x minus 1. 2x integration is x square minus 2x. X square will limit it x to x plus 1. X square will settle down in 2x plus 1 minus 2, x plus 1 minus x minus 2. Net is 2x minus 1. This is what we want. 2x minus 1 is fx, where gx is 2x minus 2. 2x minus 2. Integration will be x square minus 2x. X to x plus 1 will be 2x minus 1 minus 2x minus 2 minus 2. 2x minus 1. 2x minus 2 is gx. Now we will try computing. Gx dx from 1 to n plus 1 will give the net summation. Okay, in that manner, if I want net summation, then how much it will be? How much it will be? Okay, it will be 2x minus 2, x square minus 2x from 1 to n plus 1. Okay, x square n square plus 2n plus 1 minus 1, x n square plus 2n minus 2, and in bracket n plus 1 minus 2n. Net will come at n square. The summation is n square. Now the in examination question is written 1 minus 2 plus 3 minus 4 plus 5 up to 33. If I take only odd number 1, 3, 5, means positive numbers 1, 3, 5, 33, then what is the n I have to keep? 2n minus 1 equal to 33. 2x minus 1 we have taken. If x is 1, then it is 1. When x is 2, then it is 3. When x is 3, then it is 5. So very fit. Now if I say 2n minus 1 or 2x minus 1 equal to 33, then n equal to 17. 34 by 2, 17. Means if I want 1, 3, 5, 7, 9 up to 33 to be added, we will take n as 17, n square, 17 to the power whole square. Whatever it comes, how much it will come? 17 into 17, that will come 119. 17 into 7 is 119. 19 and 11. 17 and 11 is 28. 289. It will come as 289, I think so. So answer is 289 minus, now we have to compute 2 plus 4 plus 6 plus 8 plus 10 up to 32. Whatever comes, I have to subtract with 289 minus that much, whatever we'll get. We'll start again. Okay, what is 2 plus 4 plus 6 plus up to 32? This is the question now. Now our formula is same. Now consider this is any x, and at this x I have a height is 2. At any x plus 1 I have height of 4. What is the x when height is 2? X is 1 and a half, that is 3 by 2. 2x minus 1, 2 into 3 by 2, that is 2, 1. 2x minus 1, when x is 2 and a half, 5 by 2, then it is 4. When it is 7 by 2, 3 and a half, then it is 6. Very nice. It is following 2x minus 1 equation 1. Okay, now if I say I have a vertical at x equal to 3 by 2 as 2, at 5 by 2 as 4, at 7 by 2, at 6, at 9 by 2, as 8, something like that. It is again proceeding. What is summation of all those? If that is fx, that is 2x minus 1, then at any x equal to x, it is 2x minus 1. Then between x and x plus 1, I have an area strip that is hitting a function gx, and that area strip area area should be exactly same as fx at x equal to 1. Understandable? So 2x minus 1 equal to x to x plus 1 gx dx. Again dx will come same whatever we calculated because things are same. So it will come as 2 2x minus 2. Dx is again 2x minus 2. Let's compute the final summation. What is final summation? Final summation is when x starts from 3 by 2. And consider we have x as 1, 2, 3, 4, 5, 6, n. n. If x is n and that n is 17 where height is 33, this is what examination. When n is 17 then height is 33. We want calculation before n, that is n minus 1 plus 1 by 2. Makes sense? If this is x equal to n, then we want n minus 1 by 2 or n minus 1 plus 1 by 2, half less. Then our integration will go from 3 by 2 to n minus 1 by 2 plus 1. 1 more from half. If this is x equal to n, then half less, and then from here 1 more. So integration will go 3 by 2 to n plus 1 by 2. Make sense? Okay, that is the difference between these two. Their integration went from x equal to 1 to n plus 1. Here integration will go x equal to 1 plus 1 by 2 to n plus 1 by 2 because we want less than n. So plus 1 we will add there. Gx dx. Dx is 2x minus 2. X square minus 2x. X square minus 2x, and limit is 3 by 2 to n plus 1 by 2. Make sense? We'll try again. So, this is the solution. So, x square will be n plus half whole square minus 3 by 2 whole square. This is settled down x square minus 2, and in bracket n plus 1 by 2 minus 3 by 2. We will proceed. N square plus n plus 1 by 4 minus 3 by 2 whole square, 9 by 4. If I settle down, it becomes minus 8 by 4 minus 2. N square plus n minus 2. That's it. Minus 2, and in bracket n plus half minus 3 by 2. N minus 1. 1 by 2 minus 3 by 2 is 1 only. If I settle down, it becomes like n square plus n minus 2 and then this side it will become minus 2n okay, plus 2 minus 2 plus 2 gone. Here plus n minus 2 and minus n square minus n. This is the summation. Can someone believe on it? N square minus n. Okay, let's try. Who has stopped us? Now x equal to 1, x equal to 2, x equal to 3. Let's add 2 plus 4 plus 6. We have taken n 1 more than 6. So n will come for representing 7. If representing 7, okay, what will be n for 7? Then n will be 3, I believe. At n equal to 1, it is 1. N equal to 2, it is 3. N equal to 3, it is 5. 4. N will be 4. Let's place 4 here. In n square minus n, we place n equal to 4. 4, 16 minus 4, 12. 12. Addition is 12. Okay, that is 2 plus 4 plus 6 is 12. Yeah, it is 12. Okay, Let's add 2 plus 4 plus 6 plus 8 plus 10. If it is 10, then I have to take n away from it. And that is where, if it is 10, then I have to take n away, because this will be half. 10 at vertical is 10, then x will be in fraction. I'll take n as a whole number. Then it will come as where it is 11. If it is 11, then x equal to 2x minus 1 equal to 11. X equal to 6. We'll try with n equal to 6. N square 36 minus 6, 30. Addition will be 30. Someone can try. 2 plus 4 plus 6 is 10. Is 10 plus 10. 2 plus 4 plus 6 is 12 plus 8. 8 is, we are adding till 10. 8 is 20 plus 10, 30. Exactly, 30 only. That is n square. We had taken n as, next is 11. N as 2n minus 1 as 11. 12, 6. N as 6. Means we can calculate it. So n has been taken in both addition. The addition of odd number is just n square. Addition of all even number is n square minus n, where n is whole number, not a fraction number. Then now we have to subtract n square minus, in bracket, n square minus n. It will become just n. Just n. What do you mean? Just n. Now let's start. What is it in examination? 1 minus 2 plus 3 minus 4 up to plus 33. When it is 33, then what is n? 33 equal to 2n minus 1. 34. N equal to 17. The answer is 17. It will be 17. The summation will be 17. Someone can calculate. Because it is n and n is 17. What do you mean? Okay, try. Okay, if I say 1 minus 2 plus 3 minus 4 up to 11, then how much it will be? Okay, try now. If it is 11, then 2n minus 1 equal to 11. N equal to 6. Now, if I add all the odd number, then it is n square, 6 square, that is 36. That is 36. If I add all the even numbers, minus 2 minus 4, then it will be n square minus n. That is 36 minus 6. That will come as 30. 36 minus 30 is 6. It will come as 6. The answer will be 6. Someone can try. 1 minus 2 minus 1. 3 minus 4 minus 1 minus 2. 5 minus 6 minus 1 minus 3. 7 minus 8 minus 1, that is minus 4. 9 minus 10, that is minus 5 plus 11, that will come at plus 6 only. Amazing, mind blowing. If someone is calculating 1 minus 2 plus 3 minus 4 up to 33, then n is 17. The answer will be 17 only. Okay, this is something. Now someone would say, boss, can you try without doing the half? At x equal to 1, we have 1. At x equal to 2, I have minus 2. At x equal to 3, I have 3. At x equal to 4, I have minus 4. At x equal to 5, I have 5. Can you try like this? Rather than at x equal to 1, I have 1. X equal to 1 and a half, I have minus 2. At x equal to 2, I have 3. At x equal to 2 and up, I have minus 4, like so. This is what we tried. Can you try in x equal to 1, 2, 3, 4? First will be occupied by 1, then minus 2, then 3. Okay. Then what will be the equation? Equation will be x. X. Okay. Or x. Even number, odd number, all will be x, not 2x minus 1. Can someone try? Can someone take it as an assignment and then he can try in that manner? And let's see what it comes. Make sure that n should be representable in unique manner, not different for even and different for odd. Then only finally we can do addition or subtraction. Okay, that is the concept. Someone can try. I believe whatever we did right now, the answer is n. Someone can try more examples more examples in it. Someone can try. Let's say in examination it is written 1 minus 2 plus 3 minus 4 plus 5 minus 6 up to minus 34. Can you write the answer? Up to minus 34. If that is the case, then n is taken as a whole number. We have taken all the even number as fraction at the fraction slots. There are many slots: x equal to 1, x equal to 1 and a half, x equal to 2, x equal to 2 and a half. Like so, slot we have made. So when x equal to 17, at that time it is 33. Then minus 34 will fall in x equal to 17 and a half. 17 and a half. This is what not the n is. N should be a whole number. So we will take one more. So we will take n as 18. If 33 is represented by n equal to 17, then 35 will be represented by n equal to 18. In that manner, the summation of all odd number is n square, but we want odd number up till 33 only. So it will become n minus 1 whole square minus n square minus n. Makes sense? Where n is 18. Someone can try. N square minus 2n plus 1 minus, and then n square minus n. N square gone, minus 2n, and that side n, that will become minus n. 1 minus n is the solution. 1 minus n is the solution. Okay, this means that n I have taken as 18. 1 minus n, 1 minus 18, minus 17 is the solution. Number will come as minus 17. Okay, you said earlier that answer will be 70. Yeah, up to 33 it will be 17. Then 17 minus 34, that is the next number, will be minus 17 1. 1 minus n we are saying. Now n is jumping 1 ahead, and that is 18. 1 minus 18 is minus 17 only. Amazing, mind-blowing. Someone can try. Now this can be taken as an assignment. Can someone take function over x as x, and he can try x equal to 1, 2, 3, 4 like that only. Not 1 and 1 and a half, 2, 2 and a half, 3, 3 and a half, 4, 4 and a half like that. Can someone try in this manner? Please don't mind. Then the jumping will be 2. Odd number jumping will be 2. X equal to 1, then x equal to 3, then x equal to 5. Even number jumping will be 2 again. Earlier jumping was 1 1, but here jumping will be 2. Okay, amazing, mind blowing. In case of doubt, please watch previous video where we have talked about jumping of 1.5, jumping of 1.5, jumping of 1. Now it will come as jumping of 2. Okay, these fundamentals are not available in any of the book. Anyone can try. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.